Okay, here we go. We're going to start off with C's just to revise your skills on tree diagrams and lattice diagrams. Remember, you don't need to use them. It's just that once you see it visually, it makes it really easy to do. So, an example would be, this is exercise 9C by the way, find the probability that when a fair coin just means a coin that is fair, it's heads or tails, right, is tossed twice. Now, when it's tossed twice, what's the chance of getting one H is observed, or at least one H is observed, or both H's and both tails observed? So when we write this out, we've got to sort of figure out, okay, what are we doing? Now, one way that you learnt in sort of year 8, year 9, you learnt tree diagrams. So tree diagrams, when you flip a coin, what options can you possibly get when you flip a coin?
Half-half.
What do you mean half-half? Head, tails. So you would say, in the first branch, you can write out, you can either get heads or tails. But if I flip it the second time, okay, you would now draw another branch. You say, well, if I got heads the first go, then my second go, I can either get heads or tails. And if you did get the tails on the first go, then you got to get heads or tails. True? So what you can see, I've just used the tree diagram to illustrate my possibilities. I can either get H on the first go, H on the second go. H on the first go, tails on the second go. Tails on the first go, H on the second go, tails on the first, tails on the second. These are all my possible solutions if I flip the coin twice. I'm just using a tree diagram. So that's just reminding you of what a tree diagram does. You're just putting out all the possibilities visually for you. Okay? Now, when it says one H is observed, well, let's put out our options here. Our options were either HH, so these are my options. I can have HH, HT, TH, and TT. Now, if you think about this, what's the chances of getting only one H out of this? I've got 4 options here. What's the chances of getting one H? 2 out of it. There you go. That's exercise 9A. That's what you're doing in 9A. You're just looking at this and saying you only get to get one H. It's only these 2 options. You either get H on the first go, H on the second go. These are the 2 options you can get out of 4. So the first answer already, you'll be saying I can get 2 out of 4, which is half. Okay, so that's half a chance of getting one H. Then if you go to the second question, it says at least one H is observed. What does it mean when they say at least?
Could be one or more.
Could be one or more. So in this case here, I can either have 2, that's 1. I can have 1, that's okay. I can have another 1, but I can't have none. So that in that case, the probability of getting at least 1 would have to be 3 over 4. 3 over 4. That's 9C. See what I'm doing? I'm just revising what you've learned year 7, 8, 9, 10. Observe means like when you look at it. What's the chance? When you flip, you look at the answer. Observe, like I'm looking at you. At least 1 is what Ryan just said. He said that it has to be 1 or more. So I can only see 1 or more.
Out of all the chances,
1 or more H's. And out of them, there's only 3 of them that either has 1 or more. Yeah, so that's why you'd say the chances here is 3 out of 4. Now, second part, or third part, sorry, both H's or both tails. What's the chances there?
like 4 over 4.
Not 4 out of 4. 2 H's or 2 tails. It says or. Okay, so 2 H's, that's 1. Or 2 tails. These are the only times that I could have those 2 outcomes. So you would say it's 2 out of the 4. So your answer here, yeah, 2 out of 4, which is half. Now, just out of curiosity, anyone remember from year 7, what's the name? When you list out all your possible outcomes, there's a proper name for it. Sample space. Write that down in case they use that in the exam. When they say sample space, that just means all total of possible outcomes. Okay, so you can see that's just total possible outcomes there. Okay? Just to recap as well, does anyone remember when you write out your probabilities of getting H, you say half, chance of getting tails half, 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 half. Does anyone remember how you do this one? Where you find the chances of getting H and and T. Anyone remember? Because there's a different word. When you say or, that was this group, or this group. You add those two together. But when you say and, anyone remember what and is? So if I said, what's the chance of getting H and tails? What would you say? Because that's now a bit different. Yeah. Now, if you think about chances of getting H and tails, and means when does it occur? Both of them occur at the same time. Now, it's very different if I change the question. If I said, what's the chance of getting H on the first go, and then tails on the second go? See, now that's very specific. That means you can only get H on the first go, that's half a chance. And then another half a chance to get tails on the second go.
That would be a 55%.
Yes, it would be. And so what you would have learnt back in year 10 is this. Back in year 10, the chances, so probability, which I'm going to write in red so you can see, the chances probability of you getting H, which is heads on the first go, and, which we use this symbol here, this means and, intersection, tails. The reason why we use intersection,
Is that union?
what's common between H and T, when do they both occur together, we use that as and. Okay, so when you have H and T, in our case it is half and half. Now remember, you said it was 0.25, which is a quarter of a chance. How do you get that? It's by multiplying these branches together. So that's just reminding you what you did in year 10. Yeah, so when you go through the branches, you multiply the branches. So if I go from H to H, chance of getting H and H, you would do half times a half. That's why Brian there used logic. He found the answer was a quarter, but really, if you actually write it out, it's half times a half, because that's the chances of getting H, chances of getting tails, and a half times a half gives you a quarter. Now, if you don't like it that way, then yes, you can write out sample space and look at it from there, but I'm just showing you this is the other term. This will help you to do 9F later. Okay? So just reminding when you're going through the branches, you're multiplying them, because it's and. It's the chances. Okay? Let's try another one. Let's do the same thing. Now, I just showed you a tree diagram. Second one is called a lattice diagram, or back in year 7 and 8, they called it table of values. Okay, it just helps you to visualize the problem. So if you have a look at this one, it says find the probability that when two fair dice are rolled, so you've got two dice, you roll them, the same number shows on both dice. Now the reason why you wouldn't use a tree diagram for this, think about it. If I roll a dice, how many options do I get when I roll a dice on the first go? 6. So you would do this. 1, 2, 3, 4, 5, 6. Fantastic, Ryan. It gets too messy. See, these are 6 options, but if you roll it the second time, you get 1, 2, 3, 4, 5, 6. And then you have to do that for every single one of these options. Because you could have got one on the first go. Trent. You can get one on the first go, then on the second go, you don't know which one you're going to get. You can get 1, 2, 3, 4, 5, 6. So that means you have to do 6, 6, 6, 6, 6. It takes too long. Yeah? So, an alternative visual way to make it easier, instead of doing a tree diagram, is we use what we call a lattice diagram, which is just a table. So in the first one, you can say, chances of getting, when you're rolling a dice, you get 6 options, boys. When you roll a second one, you can also have 6 options. Now, this is easier to see. This is easy to see because that's your first go, that's your second go. Or you can say this is your first go and that's your second go. Doesn't really matter. But if I asked you now to label out what are the chances or how many options you can get, you can see it's either getting a 1 and a 1 on the first go, 1 on the first go, 2 on the second go, 1 on the first go, 3 on the second go, 1 on the first go, 4 on the second go. You can fill out this table. Now, how many options would you have in total? You're just looking at it like this. 36, because there's 6 of these options. By 6 of these options, there are 36 options over there. So if you put it in a table, it's very clear. You can have 1 on the first go, 1 on the second go, 1 on the first go, 2 on the second go, 1 on the first go, 3 on the second go, 1 on the first go, 4 on the second go, and you can fill out the table, and you can see you will have 36 options if you fill it all out. Now, answer to the question. There are 36 possibilities, but you want the same number shows on both dice. How many of them are there? Just looking at this diagram, how many of them will there be? 6. Because you got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That's the only options that you can get where both of them have the same numbers. So, if you write it all down, you have 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are the only options you can get. So when you're answering it, it's just 6, yeah, which is 1, 6. Too easy. Year 10 probability. See what I'm doing? That's exercise 9C right there. Yeah, that's what I'm saying. You don't have to do 9A, 9B to get 9C because you already learned all this. Just learn the basic skills, yeah? A and B is like, what's probability mean? So like, flipping a coin, what's the chance? If I picked out heads, you say 1 out of 2. Count sample space. Using terminologies like I used PR before for probability. But other than that, that's what A is. B is the same thing, but they call it experimental. That's the difference between the two. That's what I'm saying. If you can do C, you can do A and B. All right, here we go. So let's do B now. B is the one where most students find difficult. All right, let's work this one out. So.
Yeah, 5 and 6, 6 and 6, and 6 and 5.
Very good. Okay. Now, when you're answering part B, listening. Part B, it's all about laying out your diagram. So your diagram didn't have to be getting 1, 1, 1, 2, 1, 3. It depends on the question. Now the question says the sum of the two numbers shown is greater than 10. Now what you can do is sum. You can rewrite all of this as a sum. 1 plus the 1. This one, if you got 1 and a 1, the sum would be 2. If you got 1 and a 2, the sum would be 3. If you got 1 and a 3, it'll be 4, 5, 6, 7. Now if you fill it all out, you know, you can say 3 plus 2 is 5 here, 2 plus 3 is 5 here, 1 plus 4 is 5 here. You can fill it all out and say, that's 4, 3, 4, and you can see a pattern. Now, if you look at it, the question says, when is it greater than 10? Now, Ryan, you said, what numbers will I have to add to get 10?
5 and 6 or 6 and 6.
Yeah, if you think about it, it's only when you get 5 and 5 that gives you 10, which is right here. All these other numbers don't matter.
No, that's not greater than 10.
Yes, exactly. So because it's not greater than 10, the only other way you can get it is 5 and 6, which is 11, 5 and 6, which is 11, and 6 and 6 is 12. So you only focus on these three, and you say that's the only time you get a sum greater than 10. So there's only 3 options here. There's no point adding all of these. You don't need to. Because you're trying to find a sum greater than 10, 11, 12, and 11. There's only 3. 3 out of what?
36.
36 options. Okay, so this is much easier to do than doing a tree diagram. See, if you use a tree diagram, yeah, you can still do the same thing, but it would take ages to fill it out. But if you do a table, it's easier to see. So that's what diagrams are for. Diagrams are there to help you visualize a problem, but you didn't need to. See, Ryan didn't even draw a picture, but he can do it in his head. That's what I mean. So these diagrams are here to help you visualize, but you don't need them. You can use them if you want. Lattice diagram. Lattice. So it spells like this. Yep, lattice diagram. Okay, so this one would be 3 out of 36, 1 out of 12. Lattice, not lettuce. All right. How do we feel? Listening? Okay. That was 9C. 9D. Okay? I know. That's what I'm trying to say. Probability. I normally taught it in 4 sessions, but now I'm trying to do it in 2. So let's see how we do. Now, Venn diagrams. Let's recap on the things we learned in Venn diagrams. Anyone remember what this section is called again? Intersection, middle. Now, listening. If I got group A, I got group A and I got group B, you just told me that where they overlap is where they have in common. Now we know that the symbol that we use for common or in common is the intersection symbol. So here you would label this as A in common with B. Does that ring any bells? Yes? Now how do you label the outside where they both don't have anything in common? What do we use?
A complement.
Good. The comma, the apostrophe, we call that prime or complement. Okay, so how we write it is A complement common with B complement. Now just recap for those who've forgotten what the complement means. What does complement mean again? What's A dash or A prime mean? Not B. Akita. doesn't include A. Okay, so if I said A is all the even numbers, A dash or A prime would have to be
Excluding A and B.
excluding all the even numbers, which becomes odd. Okay, so if I said in the set of, let's say I got 3 colors. I said I got black, blue, and white. Let's say A only has the color black. Then A complement has to be what? Blue and white. Okay, it's whatever is not A. That's what A complement means. Okay, so when you look at the diagram, you say A is everything in this circle. Everything that's not in this circle, which is everything on the outside, we call that A complement. Intersection means what's in common. It just so happens on the outside, that's where it's common with not B and not A. That's why we call that not A, not B. That's where they're both in common. The hard one that most students forget are these two. How do we describe this region? Anyone remember what this region is called again? It is A, but remember, what if I don't want...
A complement.
Oh, so close. You're saying all the right words, just not in the right order. So, it was A, but what don't you want? The intersection. Now, another way of doing this is you just don't want B in there. So, if you don't want B, it's B complement. That's not part of B, but that's where they're both in common. Yeah? So that's another way. That's a short way of saying it. We're saying, I want A, but just don't put B in there. So this is where B is. I want all of A, so let's take B out. So that's where A and B, not B. A, not B. So then, what about this side? What's the other region called then? If this is A, not B,
B, not A.
yeah, that's it.
What's that? Sign in the middle?
Intersection. Very good. See what I've just done here is quickly revise your chapter 10 Venn diagrams, not chapter 10, year 9 Venn diagrams, and you're going to use this skill to answer D and E. D and E comes from this section here. Okay? Now, if you want a nicer diagram, this is what it looks like. I'm just going to rub all this off. That's the regions. They try to color code it for you, so you can see A is all the red colors. This means A, so have the red color, but I don't want anything to do with green. So this is where only red is. This is where only green is. So have B, the green color, but not have any reds. Here is mixed red and green. Here, don't have any red, don't have any green. That's what I mean. So no green, no red, no green. Okay? That's sort of the color coding, that's what we're saying. Now, I want you to copy this formula down. Let's go, boys. That's cool. You're going to be likely using this in the exam, so I want you to copy this down. Okay? It's likely to come up anytime you're using Venn diagrams, you'll be using this formula. Oh, speaking of which, thank you. There was a last minute announcement about your exams. You can bring in a bound reference for your exam.
What's that mean?
Which means like a cheat sheet, but there's no limits on it. Now, the only thing you can't bring is your textbook. Okay? So in the past when we said that, most students would just bring a textbook. Because this is...
Can we just photocopy that?
No way! This is called a bound reference. Bound meaning that is together.
So
okay?
photocopy it?
Yeah, you can if you want to. You're willing to put in that effort. And I'm almost guaranteed that you guys are going to put that effort to do that. Okay? So, yeah, you can do whatever you want. Anyway, how many pages? I just told you. Huh? I just told you. Year 11, this thing, this one's going. I'm just about to get there. So, conditions. This thing. What does it mean by bound? Hey guys, I'll bring this whole thing. Alright, you bring the whole thing. Great. Excellent for you. Can I explain that you don't have to ask me individually? Alright, what does it mean for bound reference? Literally, whatever you're bringing in has to feel like either an exercise book or like a textbook. Because when I shake it, nothing comes out. There are no tabs. It is not bigger than an A4. It's not like an A3. Okay? You can have an A5 if you want, but nothing bigger than an A4. It can have spirals, but nothing that you can replace, put in. So you know those spirals where like this, take out something and put it back in? It has to be when I shake it.
You kind of like a display book.
Yes. So, when you bring it in, an exercise book is generally great. That's what most Year 12s do. But you don't bring in a textbook because we're trying to get you guys to do so. We bring in this.
Well, as soon as it in
No limit as well. Oh my God.
No way.
You can, but it has to, like when you shake it, nothing falls out.
How about
Alright, you 11s, lie down. Lie down. Oh, no, you lost it.
Nice try. So we have a
No, so no textbook. No textbook. Just can't bring a textbook.
So can we bring in like a passing example?
Sorry? Can you? No textbooks. No textbooks.
So we bring in like a passing example.
Bounded. Has to be bounded. All right. All right, 11's listening. Lie down. Trent. Thank you. Remember, we've only got a double session. Lauren. Thank you. Will, you're not helping.
Will, you're an idiot. Go ahead in.
Thank you. All right. Enough with the bound reference stuff. So, like I said, just treat it, when you make it, it has to look like an exercise book or your textbook. Just keep that in mind. No. Does that look like an exercise book? No. If it feels like an exercise book, then you got it. I don't understand how hard that is to understand. I believe it's only for the calculator section.
So is there two sections?
There's two sections.
There's only one time frame.
Then it most likely, maybe that's why there's a last minute.
So the whole thing is.
There will be a section without it, I'm pretty sure. I haven't actually seen it. It's two parts. I'm not sure. I'm gonna. All right, you 11s.
What we said, Coach.
Can we settle down, guys? Ryan. Thank you. I don't want to talk about this reference book because you guys are going on about it, and I promise you, it's not going to be useful when you walk into that exam. Sounds all good, but I promise you, you write whatever you like. It's about how much you know it. I can give you a textbook, it won't change a thing. Like even with your SAC, quadratic SAC, I said bring your textbooks in. How many of you successfully did well in that SAC? It's not going to help. So can we focus on probability right now? Stop talking about your references because it's not going to make a difference. Okay? Here we go. Now. Yeah, you meant to copy it before. You had a lot of time. But anyway, here we go. Let's look at this example. I want you to copy this example down. Anyone remember what this symbol means again? What's that? Element or a member of. Another way from your textbooks, normally they write like this. They write it like that. What does that mean again? It is the same thing, but there's a proper name for it. It's called the universal set. Now set means group. Universal set means the entire... No, you don't have to draw it. The entire group of elements that you can have, or things that you can have in there, is only 0 to 5. Okay, so that's what it's saying. It's just saying in this group, I can only have 0 to 5. Now, if I then told you the group A, which is set A, has only 0 to 5. If I made another group and I called it B, which is a set, and I said it only has 2 to 3. Now I want you to fill out these things that we just learned, all the symbols, and let's try to fill this out. If I asked you to represent a Venn diagram, we know how to represent it in a diagram, but before we do it, I want you to figure out what's in common between A and B, because remember there were 4 sections that you need to know. A intersection B, A complement intersection B, B complement intersection A, and then A complement intersection B complement. You needed to know those 4 sections, yeah? So let's work it out. What's in common with A and B right now? What's common between A and B? 2. So we write 2. Because they both have a 2. Next one. What if I asked you what's in A that is not in B? So if you look at these 2 sets here, what's in A that is not in B? 0. Okay, because you can see B, not in B, has to be 0, 1, 4, and 5. So what's in A that is in not B? This is not B. And what's in A, you can already see they're both have 0. So it helps if you write out what's not in B. Okay, what's not in A then? If you know that's not in B, what's not in A? What don't I have in A? See, all the numbers I have is 0 to 5. Now A has 0, 2, 5. What am I missing? 3? And 3 and 4. And 1. Okay, so that's what we mean by A complement. A complement means not in A. So in the universe I had 0 to 5. I'm missing a 1, I'm missing a 3, I'm missing a 4. For A, yes? That's called a prime or complement. That's what I've been saying before. It means, yeah, little dash, prime, okay? Now, if I asked you what's not in A, you told me it was 0. I mean, what's in A that's not in B, you told me it was 0. What about the other one? What's not in A but is in B? So what's not in A that is in B? What do they both have in common? 3. You can look at the list, you can say they both have a 3. So you can say here, 3. Finally, what's not in A and what's not in B that are in common? So these two lists here, what do they have in common? Second one.
The A intersection dot B. Yeah, 1 and 4.
Oh, you're right too. Thank you. Okay, and A, not in A, not in B, what you can see is they both have 4 and 1. Okay? Now that you've got your 4 regions, when you draw out your Venn diagram, that's what exercise 9D is about, you can fill this one in. Here we go. So let's call this A. Let's call this B. What was this region called again?
A intersection B.
A intersection B. So if you were to fill it out, what's in A intersection B? 2. So what's in common between the two? They have a 2. Okay? What is in A that isn't in B? What's in this region that's not in B? 0, 5. So I can say 0, 5. Now that makes sense because if I just look at the circle of A, it has 0, 5, 2, which I have 0, 5, 2. So that makes sense. My diagram represents that. Then I look at B. See B, this section here. What section is that called again?
Just B.
Just B and not A. So B not A is this one, which only has 3. Which makes sense because if you just look at the circle for B, it only has 2, 3. Which makes sense. B only has 2 and 3. Okay? But I got 0, 5, 2, 3. What numbers am I missing? What numbers am I missing? 1 and 4. See, right on the outside, they don't fit in. So when you can see here, this is the Venn diagram. That's exercise 9D. That's all you're doing. You're going to get a whole bunch of different questions. Your goal is to put them in the diagram correctly. Okay? I'm going to do some examples of that. Now here, this table over here, that's what 9E is about. Now you're going to have to learn how to use these 2 regions to put in here so you can do 9F. And that's why I'm spending this first session. We're going to be doing that. Then we'll do the second half of this session on 9F. And that hopefully we've got a double session on that. So 9F today, 9F Friday. Hopefully you get an idea of how to do 9F. But that's what you need. Okay, so Venn diagrams. Now how do we put it to this table here? How this table works, I'll show you on the side. Whoops. How this table works, I want you to copy this down. This is called a Karnaugh Maps. If you remember back in year 10, Karnaugh Maps. All you're doing is you're literally writing what you see here. Okay? And then you can add them all up and you can figure it out. So in this case here, first column, you've got to set A. So I'm going to write down A. That's my A. Next to it has to be not A. The other one is my option, which is B, and then I don't have B. See what I'm doing there? I'm just putting out my 2 sets. I got set A, number of things I can have for A, number of things I can't have for A. On the row, I've got number of things for B, and number of things not B. Okay, so 2 things there. Now, when I did the Venn diagram before, we're just trying to transfer the number of items you have to see if it all matches. Okay, now, when I do this, I'm really just saying, notice I'm using this N in front of each one of these. Does anyone have an idea what N might mean? Number. Literally. And I want you to write on the side, this just means the number of items. B. Number of items not in B. Number of items in A. Number of items not in A. Now you can count that just by looking up here. There's no issues here. You can look at it and you can say, what's the number of items in A and B? Okay, so A and B, we only had one. There's only one number that was in common. So we can say here, I want to label it in here so you can see. I'll label it in blue and I'll highlight it. So this section here is saying what's in common, number of items I have for A and B. This is A and B up here. There's only one number. So what you're going to write is you'll say one item. That makes sense. What about the number of items in A but not B? How many items in A but not in B? So if we look at it, A but not B, there's only 2 items. There's 0 and 5. 2 items. So what I'd write is 2. Now if I asked you, what's the total number of items for A? You got 1 and a 2, so 1 plus 2 gives you 3, which makes sense. 1 plus 2, I get 3. That makes sense. This is the total number of items for A, so that makes sense. That's the total number of items for A. I've got 3. Number of items for A, I've got 3. 1 plus 2 is 3. Yeah? How many items aren't in A? Or how many numbers are in not A? Listening, 3. 3. You can look up here, you can say there's 1, 3, and 4. There's 3 items. That means this has to have 3. Now if you think about it, if you add 3 and 3 across, what does this number represent here? What's 3 plus 3? 6. But what does the 6 tell you? Total. Which makes sense. 1, 2, 3, 4, 5, 6 numbers. This is just called a Karnaugh map. It's meant to all add up. Okay, so if you think about it, what number goes in this region here? In B but not A. What's in B and not A? How many items do I have? 1. How many number of items do I have? Not A, not B. 2. Makes sense. 1 plus 2 is, it makes sense. So this is 2, 4, and that still gives you 6. So what I've done here is I've just put together, this is the Karnaugh Maps to represent the number of items per region. This is the 4 regions you have. Okay? That's all the 4 regions of your Venn diagram. That's exercise 9E. Okay, that's what 9E is about. So 9D, Venn diagram. 9C, diagrams. 9E, transfer Venn diagram to a Karnaugh map. For those who don't know how to spell Karnaugh map, I'm going to write it down. Karnaugh map. Karnaugh map. But that's what 9E is. So you're going to be using 9E to do 9F. So I need you to practice this. In order to practice this, you need to know how to do Venn diagrams. But hopefully you understood Venn diagrams already. You can start here. That's what my worksheet is about. Okay, so this worksheet here, I've got only 3 questions for you to work with. Transfer a Venn diagram to a table or Karnaugh map. And the answer's in the back. And the answer's on the back here. Then we're going to work 9F for the second half session. But that allows you to summarize chapter 9 pretty much 3/4 already. Okay? You just got 9F to work on. That's what I mean. I've always taught it in 4 sessions. This is the first time I'm doing 3 sessions, so we've got a double today, 1 session next. That's fine. Okay? But it is easy to do. That's what I mean. Probability is much easier to do than any other chapters. That's why it's possible to do. Okay? All right, let's try this one. Just in case you're still having troubles with Venn diagrams and then transferring to Karnaugh maps, let's do this one. One example, and I'll give you the worksheet, and you can work on that for 15-20 minutes. And we'll probably then talk about 9F. But at this point, let's do this. Here we go. Last example for today, or this session. If one card is chosen at random, listening. If one card is chosen at random from a well-shuffled deck, now just in case you don't know how many cards are in a normal set of cards, 52. Okay, if you didn't know, there are 52 cards, okay? So 52 cards, what is the probability that a card is a king or, so the keyword is or, a spade. Okay, now, how many kings are there in a deck? There's 4. There are only 4 kings. How many suits are there?
4.
4. There is a diamond,
Flower.
heart, clubs, and spades. There's only 4. Now, how many cards in total are there? There's 52, but how many different ones are there?
I assume this is standardized set. 0.3077.
I'm not asking the answer. I'm asking you, how many different cards are there? There's an ace, there's a 2, there's a 3, there's a 4. How many of them are there?
13 for each.
13. 13 with 4 suits, that's why 13 times 4 is 52. Now, to answer this question, you have a choice of either getting a king. That's a king there, so I want you to copy this down. Venn diagrams, yeah? King or a spade. Now, listening. There we go. This circle represents the number of cards that are kings. This circle here represents the number of cards that are spades. Now, in the center, you told me that's where they're both in common. So how many cards are there that is a king and is also a spade? How many? Will? Someone said 1.
Yeah, I said that.
All right, sorry. Yes, 1. We know there's only 1 card that is a king and is also a spade. So this region here represents king and spade. The middle. Okay, so the one I've just highlighted. Right here. Because you have 4 different kings. You have a king that is heart, king of hearts.
Oh, right, yeah.
So this is king of spades, yeah? But there's only 1 of them, so I put a number 1 there. How many other kings are left over? Oi! Thank you. You already told me there's only 1 of the kings has a king of spades. How many other kings are left over? 3. You got kings of diamonds, kings of hearts, and kings of clubs, right? So I've got 3 left over. So that makes sense. In the circle of kings, in this circle here, I only got 4 cards. This makes sense. You told me there are only 4 cards that are kings. Let's have a look at the next one. Spades. 13. There's 13 in total. Now one of it is a king, but the others aren't. So how many aren't kings? 12. Okay, but that doesn't make sense because now, if I add them all together, 3 plus 1 plus 12, I think gives me 16. But we told each other just now, we said there are 52 cards. Thank you. So whatever goes on the outside is not a king and not a spade. Okay? So how many there aren't kings and spade? Well, you just told me there's 16 here, so what's left over? 52 minus 16. Okay, so whatever that is, which is 42, take away 6, 36. Very good. So there's 36. Can you see what I just did there? That right here is the exercise 9. Exercise 9E D here. Okay? This is now 9E. So let's transfer this to a Venn diagram. I mean to a Karnaugh Maps. Okay, so Venn diagram. Let's transfer it. Here we go. How many number of kings and spades? How many cards do I have that are a king and a spade? 1. So this section here has to be 1. How many kings that is not spade? 3. What? Yes, you're right. In total, 1 plus 3 gives you the total number of kings, 4. How many cards that aren't kings? See, what's the total again?
36.
Yeah.
39.
Now, you know there was a total of 52 cards. There has to be 48 cards that aren't kings. Yeah, so there's 4 of them that are kings. Total is 52. That has to be 48. Now let's work out this one. How many is that is not a king, that is a spade? Not a king, but a spade. Not a king, but a spade. So we write 12. So right here, 12. How many of them is not a king? 36. So this has to be 36. Add them together. 39, 13. So now what you've just done here is exercise 9E. See, 9E will ask you different questions. They might say, what's the total number of spades? 13. What's the total number of items that is not spade? 39. They might ask you, what's the chances of not getting a spade? You would say it's 39 out of 52. If they ask you, what's the chance of you getting a card that is not a king, but is a spade? Then you say there are 12 cards out of 52. That's what 9E is all about. So you can see a lot of the skills come from everything before do 9E. Okay? That's what I want you to do for this session. Okay, so I'm going to give you 15-20 minutes to work on only 3 questions. Okay, 3 questions. The more practice you want to do is in your exercise books, but this should be enough for you to understand. Okay, there's only 3. 1, 2, 3.
Yeah, okay.
Alright. Here we go. And to pause the video, what I want to do, grab one.
Should we get 12 marks for that?
You have to grab one.